Today's example is titled as an machine shop. This example comprises a workshop with the number of and identical same machines. And also the same jobs are arriving with the given inter-arrival time. And each machine breaks down periodically. And also, when the machines are broken, the repairs are being carried out by the assigned repairman. And also, this repairman has other jobs, his own jobs, but the priority is higher in case of the machine failure. So this repairman may work his own jobs when the machine have no broken states. However, as soon as the machine is broken, this repairman have to leave his or her own jobs and go to the broken machines, and he have to repair that and come back to his own jobs and conduct the jobs with the remaining times. And in this manner, this machine shop is being continued. So let's see some animation. In normal condition, when there is no machine broken, each machine is doing its own jobs. But when one of the machines are being in the broken state, then this repairman have to come to this broken machine, and he or she have to repair these machines. But this repairman's job have the lower priority. So it's called the other job. This other job is being waited until this repairman is coming back to this other job. So in this case, in terms of this other job, this job have to record the remaining times. And this repairman, when this repairman is coming back to this other job, the repairman will conduct the work with the given, it means the saved remaining times. And a machine may have two processes. First one is working. Working implements the behavior or operation of the machine. And second process is the break machine. And this break machine process periodically interrupts the working state process in order to simulate the machine failure state. In this example, there is two important concepts. First one is interrupt. Interrupts are function which stops a process, even though that process is being in progress state. By use of this interrupt function, we can stop the process that in progress. As shown in this figure, when an interrupt of SimPy occurs by using the except. We'll see the whole command or statement. By using the except statement, the event is stopped at the point of this interrupt occurred. So after this slide, we'll see the entire code, but this is the selected. And with this except means that if there occurs the interrupt function, and this interrupt function is belonging to the SimPy library, and if the interrupt occurs, then a certain kinds of attribute is being changed to another value, and in this variable, the remaining times are recorded. And after this, in order to resolve this interrupted problem, the kinds of resource are requested by use of this with phrase and yielding the event, the requirement. And after this, if in this case, if the repairman is becoming available, then go to the next generator and consume a certain amount of time that is in here. It is repair time. And second important concept is the preemptive resource. Preemptive resource is a kind of resource that can have a priority attribute. The default resource is used sequentially in the order of in which the requirement is triggered. But the preemptive resource have the priority. So preemptive resource can be considered when that assigned resource is requested from multiple processes. And by assigning the priority, then the multiple processes require this resource simultaneously, then according to the defined priority, that this resource can be assigned to the higher priority requested element. It can be done like this. Normal resource is handling the request as the triggering orders. So there is no priority. The requested event is being treated sequentially with the order of the generation. But in case of the preemptive resource, and there is a request with the priority 2, but if there are arise of the request with the priority 1, this priority 1 can interrupt the other request and being called with the higher priority. So with these two key concepts, we are going to implement this was the machine shop problem. A little bit more complex comparing with the previous two examples. And this example will give us more the flexibility in the simulation modeling, because there are so many status of the interrupting the process by stopping, and also there can be many cases that require the priority the considerations. Before investigate each line by line, let's see the entire code first. There is the import random package and SimPy package, and there is a global variables defined, and there is a two function for the time distribution, one for the working time and one for the time between the failures. And there is a machine class, and inside of this class, there is three the sub function. First one is the init function, and second is a working, and third is a break machine function. And all these functions are belonging to the machine class. And there is an independent process, that is function, called other jobs for the repairman itself. And this is the entering point of this program. And very shortly, environment, definition, and definition of the preemptive resource for the repairman. This repairman's work is two. First one is his or her own jobs, that is called other jobs. And second one is to repair the broken machine. And here, the machines are created with the defined class. And also, the other jobs is being modeled in here by use of the process command. And this simulation is being started by running with the defined simulation time. So let's see the internal code line by line. First line is a random seed, and you can change this number anytime. And this processing time, mean process time, and the standard deviation. So these two variables are used in this time per part. This means the working time. And MTTF means the mean time to failure. It means the time between the occurrence of the machine breakdown. And this is the definition for the use of exponentiate function. Actually, this is the exponential distribution, but we have to use the reciprocal number of the MTTF that is being defined as break mean. Because if we remember the exponential distribution, the parameter is being defined as 1 over the mean time. That mean time is defined as lambda at the times. So this is just the reciprocal number of MTTF. And repair time is being defined as a fixed number, that is 30 minutes. And the duration of other job is 30 minutes or so. And initially, the number of machines in this example is defined as 10. And simulation time is defined as a week. And actual simulation time is calculated as the multiplication of weeks and 7 days, 24 hours, and 60 minutes. This is just time converting. And for the modeling of the working time, the independent function is defined with the name of time per part. And this function has normal variate function. It means that normal distribution. So the argument is have two parameters. First one is mean processing time, and second one is standard deviation. And next is time to failure. This is also defined as a function, a separate function, and used distribution is exponential. And in the second part, create environment and also define the repairman as a preemptive resource. And also creating the machines as machine object. It means that machine is already declared as the class here. And also the process other jobs with input value as an repairman. This preemptive resource is being input to the argument of other jobs. It means that this other job may use or may require this resource. So now we have to see what is being coded in the machine class. In definition of a machine class, is started with the init function define definition. The argument is self. Self means the machine, and environment is being transformed from here. And also name was assigned here with the number of I, and this I is generated from 1 to 10 because we have defined this number of machines as 10 in the global variable parts. So environment is being defined as a self variable. Also name is the same way. And in the start of the simulation, in order to record the number of parts that is being produced, this self.parts made is being defined. This variable will be accumulated by machines. And the initial state, the state variable that is broken is being defined, is being assigned as false. Because in the start of the simulation, each machine may have the broken state. Now let's see what is being coded inside of the working function. In this working function, we have got the repairman resource. Because if the machine is broken, we have to use this repair. We have to require this repairman. Is it okay? The speed is okay, or a little bit slow, or a little bit faster, or moderate? Okay. And in this working function, by use of while, this function will not be stopped until the end of simulation because the true is assigned here. So there is no stopping point inside of this function. And when the start of the simulation, when the start of the working function, this time per part function is being called, and the random variable that is created in this function is being transferred to this variable done in. And again, in the while loop, this value of done underbar in may be positive number. It means a greater than 0. So this while loop also have no stopping point. Only except this occurrence of the interrupt. So if there is no interrupt is being triggered, this motion function will trigger this timeout. In here, you have to notice here that current simulation time is recorded here in start. Because if the motion is broken and this motion have to be repaired, this remaining time have to be saved somewhere. Because when this motion is repaired and come back to the normal state, then this motion have to the remaining jobs. In that point, the recorded time will be used. And when the work is being finished without the motion broken, then insert the 0 number in this variable. And this variable, by assigning this 0 variable, this while loop will be finished. But if during the progress of this timeout, if the interrupt event is occurred, then this timeout is being stopped at that point, even though this process is not finished. Instead, firstly, change the state variable broken to the true. You will see why you will know, you will get to know why this variable is changed to true in the brain machine function. And where is it? The remaining time is being saved is this variable by extracting this start time from the current time. This is the remaining time of the certain jobs that is being conducted. And after the save the remaining time, then require the repairman. And by assigning the priority as 1, the first priority, this repairman will be attached to this request, even though this repairman is doing his own, the other jobs. So by adding the request event, this repairman will come to this machine because there is a priority 1. But please remember that if there is some more requesting event with the same priority 1, this will be handled as a normal resource, because if the multiple resource are requesting the same resource with the same priority, that is being handled as the normal resource. It will be triggered by sequentially in the order of the occurrence. And by requesting the repairman, and if the repairman is available, then this generator will be triggered with the given repair time. And after this, change this state variable broken to the false. This is the pair with this line. And after this, where this program goes to, where goes to after the completion of this repair, where goes to? Anybody knows where goes to? Where are we after the completion of this repair? Nobody knows? We are still inside of this while loop because when we goes into this interrupt with except, before this except with the interrupt, we were in this line. We did not finish the given jobs. So this done underbar in variable is still have the positive number. So we are going back to here. Again, back to the try line. And in this line, in this case, this line is not that the U, then it's not have no meaning. Just goes to this line with the remaining time that is done on the right, because we have saved the remaining time in this variable here. So after the completion of the machine repair, we are going back to the try, and also again the save the current time to the start, and doing the remaining jobs here. But with the very low probability in this during these jobs with the remaining time, with a very low probability, the machine can be broken again with the very low probability. But there can be the second failure occurs even in these single jobs. At the case, again to go to this interrupt again and change the broken state variable, and this variable is changed to the remaining time again. But if there is no second broken, the machine broken, then in this line, this machine may finish the work with the remaining times. And by assigning this zero variable in zero value in this variable, finally this while loop will be finished. Okay? Can you follow me? And going back to this endless while loop and starting again the next jobs here. No. Before going back to this endless loop, the parts made attribute is being increased by 1. And this is saved to its own machine's variable. So if there is 10 machines, each machine may have its own parts made variable. So after the completion of entire simulation, and if we want to know how many parts are being made in the whole 10 machines, we have to sum all of the parts made variable of each machines. Okay. Then next go to the break machine. This break machine function is also being included in machine class. In this function, also have endless loop with the true value and iterating this yielding event with the given value, that is time to failure. And we have already defined this time to failure function as an exponent. I cannot remember what. Time to failure as the exponential distribution. So every period of this time to failure value, and if the specing machine and the state is not broken, that is the reason why we have changed this value to the true. Because if this machine is in states of broken, then this break machine will not trigger the broken states again, because this machine is already in state of broken. Okay, so only if this machine is not broken state, then trigger the interrupt function here. And by triggering the interrupt function here, this interrupt function impact here. So this is like the shake hands. It means that only when this motion is in state of progress, it means that only when in this states here, this interrupt function can be effective. And last one is the other jobs. This other jobs is the jobs with the second priority for the repairman resource. Also, this job have endless loop here. And in the same way with the working function of the machine class, this variable done under by in is defined. And here, the job duration is coming from the global variable that was maybe 30 minutes. First, let's start with this while loop with the positive number of this variable. And in the start of this function, this other job requests the repairman as priority 2, second priority. So if there is no machine breakdown, this repairman is always doing these jobs. So by requesting here, generating this request event, and here start the machine. But there have to be no interrupt. And save the current time to the start variable and starting the other jobs. And if this job is finished without the interrupt, this variable is changed to 0. And by changing to 0, this while loop will be finished. But if the interrupt occurred here, this interrupt will stop the working, also stop this working of repairman's other jobs. And only treatment of these other jobs is save the remaining time here. So after the completion of a repair, then coming back to here, and this variable is going to here. And by requesting the repairman, and here, this repairman doing this other job doing his or her own jobs with the assigned remaining times. Okay, can you follow this example? Actually, code is not complex. However, the interaction between class and object or functions a little bit complex. And I think that this code is very beautiful because even though this code is very simple, but the mechanism that consider the various kinds of status. The state includes the machine jobs, other jobs, and also the machine breakdown. And each jobs had each event or each entity has their own the random distribution. So by use of very similar structure inside of the working object and other jobs object, we can implement the very complex, the expected complex status. Okay, this is the end of the explanation of this example. And finally, let's see the structure of the code. Initially, an environment object is created. Next, the motion object is created and the process. The method of the environment object. Here, inside of any function, there is a variable instantiation, there is an environment, the motion name, and also parts made for the purpose of the recording the number of parts created in each machines. And also this broken variable is very, very important in this example, because by using this broken variable, the motion class and other jobs can, the repairman can is able to handle the very complex situation. And in process definition, there is the trigger, the make a model of the working with the repairman assignment. Also, the working process and brake machine process is being started simultaneously. And that is a parallel process. So working process is started, also brake machine started. During the motion process, if the interrupt function is being triggered, this interrupt have impact on the motion by stopping the working. Also stop the repairman's other jobs. And repairman goes to the machine in order to repair the machine, because that has a higher priority request. And after the completion of the repair, can you remember some terminology that those are used in SimPy? At there, the request and release function in resource description. But the new version of it means the current version, the version 3 and version 4, there is no more need to use this release explicitly, because after the completion of this job, this resource is released automatically without the explicit announcement of the release function. We come back to the other jobs again and doing the jobs with the remaining times.